So, continuing on from what we talked about in section 1, I told you that there were 3 ways you can solve systems of linear equations. The first one we did in section 1 was by graphing. The second way of solving is by what is called substitution. Now, there are several steps that you need to keep in mind in order to solve using substitution. These are the steps that I have right in front of you. First step is when you get a system similar to, like, we have an example A. Oh, excuse me. First step is we must solve for one variable or get one variable by itself. Now, it does not matter whether it's x or y. We just need to get one variable by itself. Once we do that, we can substitute in that value into the other equation. Once we do that substitution, we solve for the variable that we have in there. Once we solve for that one, we substitute in that result and then solve for the other variable. Now that may sound complex with those steps. Here's what we do. So we have example A as y equals 3x plus 2 and x plus 2y equals 11. So first step is we need to get one variable by itself. And if you look, we have a y equals already in our first equation. So it's y is already by itself. So step 1, it was kind of already taken care of us for this example. So now I must go into step 2. Step 2 is then you substitute that value into the other equation. So if y equals 3x plus 2, you see where I have y right here? I'm going to replace y with 3x plus 2 because I already know that that equals y. So I'm going to rewrite this equation as x plus 2 times 3x plus 2 because that equals y. All equals 11. Let me get some more room. Let me extend the page. There we go. Okay. Now that I have substituted our value, now I can solve for the variable. This time I'm solving for x. So I have x plus, now I'm going to distribute my 2. So 2 times 3x is 6x. And 2 times 2 is plus 4 equals 11. I'm going to add up like terms. I have an x and I got 6x. That leaves me with 7x plus 4 equals 11. Subtract both sides by 4. Gives me 7x on the left-hand side and 7 on the right. Dividing both sides by 7, I get x equals 1. So that is my result for my first variable, x equals 1. Once I do that, we go back to the rules. So once I solve for that variable, now I substitute in that result and solve for the other variable. Now it does not matter which equation you use. I'm going to use this one. So I'm going to substitute in my 1 in for x. So I got 1 plus 2y equals 11. I'm going to subtract 1 to both sides, which leaves me with 2y equals 10 divided by 2. Y equals 5. And it would be the same thing if I were to have used the equation on top. I still would have gotten y equals 5. So my coordinate would be 1, 5. And what this is telling us, just like it was from section 7.1, That is the coordinate where the two lines intersect. And that's what we're looking for when we are trying to solve for systems of linear equations. Again, these are just a friendly reminder of the steps that you have to do in order to solve it. We're still using the substitution method and solving for our equations. So I have, for my next example, I have x minus 2y equals negative 6 and 4x plus 6y equals 4. I'm looking at the easiest one to get the variable by itself is I think I'm going to solve for x on this top one, and I'm going to add 2y to both sides. So that cancels, leaving me with x equals 2y minus 6. So that's step one. I got one of the variables by itself. Now I'm going to substitute in x right here. I'm going to use it as 2y minus 6 because I've already established that x equals 2y minus 6. So I can substitute it in. So now I have 4 times 2y minus 6 plus 6y equals 4. Now I'm going to solve for y. So I'm going to distribute my 4 times 2y is 8y minus 6, so that's minus 24, because 4 times 6 is 24, plus 6y equals 4. So I combine like terms, I got a 8y and a 6y, that leaves me with 14y minus 24 equals 4. So I'm going to add 24 to both sides, so it cancels out on the left-hand side, and 24 plus 4 is 28. Divide both sides by 14, which then gives me y equals 2. So now now that I've found my result for one variable, I substitute it in back into the equation and find x. So I'm going to use the first equation. So I have x minus 2 times 2 equals a negative 6. So x minus 4 equals a negative 6. And I'm going to add 4 to both sides, which gives me x equals negative 2. So my coordinates here are negative 2, comma 2. Negative 2 is x, 2 is y, and that is the intersecting point for those two lines. Let's look at this one. So I have negative, not too far. So I got 0.2x plus y equals a negative 1.8, and I have 1.8y plus 5.5x equals 27.6. And for this one, I find that this will be the easiest one to get a variable by itself, and I'm going to solve for y. So I'm going to subtract 0.2x to both sides, leaving me with y equals negative 0.2x minus 1.8. Now that I've gotten a variable by itself, I'm going to substitute it in into the other equation. I have my y, and I know my y equals negative 0.2x minus 1.8, so I'm going to go 1.8, and now I got negative 0.2x minus 1.8 plus 5.5x equals 27.6. Now I'm going to solve for x, so I'm going to distribute my 1.8, which gives me negative 0.36x minus 3.24 plus 5.5x equals 27.6. Like terms, I got 5.5x, I got a negative 0.36x, which leaves me with 5.14x minus 3.24 equals 27.6. I'm going to add 3.24 to both sides. That cancels that out. Leaves me with 5.14x equals 30.84. And if I were to divide 5.14 to both sides, my x equals 6. Now, all I have to do is plug it back into the original equation. I'm going to use this one. So I have 0.2 times 6 plus y equals negative 1.8. 0.2 times 6 is 1.2 plus y equals negative 1.8. If I subtract 1.2 to both sides, y equals a negative 3. So that means that my coordinate that it intersects is at 6 comma negative 3. And that, excuse me, and that is solving systems of linear equations by using the substitution method. Hope this helps. Until next time.